Hi there, and welcome to this demonstration of using Sonic Pi version 2.11 to record a 4-voice round of Frere Jaques, but the twist is that there's only one voice recorded. The recording is possible because of a new feature which has been added to version 2.11, which is the fact that we have a synth called Sound In, and this enables you to use a microphone input to be recorded as part of the program that you play in Sonic Pi. I'm using a cheap plug-in USB audio card called Sabre NT. It's only about a £5 from Amazon, and I've got a small cheap microphone plugged into it to get my audio input. The program is going to record the sound by means of this live loop here, which repeatedly triggers the synth for a short period of time, equal in fact to the time for 2 crotchets to play in this piece, and then it sleeps for 2 crotchets and the whole process repeats indefinitely. In order to stop the live loop, I've got a variable called killit, which is initially set to 0 but will be switched to 1 at the end of the program down here when we want to stop the microphone input. One of the important things if you're trying to play around is to make sure that the singing is absolutely in time, and to this end we start the program by means of a metronome, and this section of the program does that. We have a stream of notes, a C6 high note followed by 3 C5s, which is repeated twice, and then a C6 arrest, a C6 and a rest. And that, if you like, is the sort of intro just to set the speed before we start playing the tune. The tune is played in the next section. We have a list of notes followed by a list of corresponding durations of those notes. The notes, if you look at the first of those highlighted lines, are C4, D4, E4, C4, which sounds something like da 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 da, repeated twice, and then we get E, F, G, repeated twice, and then some faster notes, G, A, G, F, E, C, that's repeated twice, and then finally C, G, C, repeated twice. And the corresponding durations to those notes are in the following line, signified by Q for a quaver, C for a crotchet, SQ for a semiquaver. And the relative times of those notes are set right up at the start of the program here. You can see the relative times, quaver being half the duration of a crotchet, semiquaver half the duration of a quaver. We're using the synth beep because we only want this as a small background. We don't want it to be too prominent, and I've set the number of beats per minute to be 50. So that gives a brief indication of the program. Both of the metronome and the notes use the play pattern timed command, which is followed by the list of notes, in this case N, and the list of durations, in this case 1 duration shown. What happens with the play pattern time command is that if that list is exhausted, it just starts reading it again from the beginning. So every note has a quaver duration. So let's set this going, and what we want to do is to play these together so that the audio of the voice as I sing and the notes played by the beep synth can be merged together and recorded by Sonic Pi. So let's start this. I won't say anything more other than sing until the recording has finished.
Frere Jaques, Frere Jaques, dormez-vous, dormez-vous, sonnez les matines, sonnez les matines, din dan don, din dan don.
So we stop the recording and save it. I'm going to call it F Sing, and we'll save it there and ask it to replace the previous version, which is there, and that completes our recording. So to continue, we can now switch to the next buffer, where I've got a very simple program done, which is simply going to play our sample. We'll just get rid of that actually, that's coming up a bit later. Here it is, sample, and there's the name of the sample, and here it plays.
Frere Jaques, Frere Jaques.
Now we won't let it play all the way through. The important thing is that we want to get rid of the first bit, the pause before anything happens, and then the intro, which we don't really want to play in the performance. So we're going to use one of the new features of Sonic Pi 2.11 to do that, which is the addition of an onset parameter, which we can put in here. And basically this is triggered every time there's a sharp change in the amplitude of the waveform. So if we ask for the first time that happens and we run the program, that plays the first beep of the metronome signal. If we change that to a 1, it will play the second one, and so on. So we'll now put back the bit I just got rid of, which is this. And instead of putting in the number here, we're going to get the computer to work out the number to put in there. I'm going to use the tick command, and in a loop what tick does is that every time you come across the word tick, it will increment its value by 1. So the first time we get there, tick is going to be 0, and we get onset 0, which is we've just listened to, then onset 1, and so on. And I'm simply going to separate the playing of these different onsets by the sleep variable there, giving half a second delay between each one. So let's listen to that. Now, you'll notice that it plays all of the metronome ones. You'll notice too, we'll listen to it again in a minute just to so you can look for this, that the last two beeps, which actually have a rest between them, just play continuously because the rest doesn't signify in the onset command and so is ignored. And the very last low note is just the beginning of the tune playing. And what we really want is the time that that occurs. But let's just listen to this one more time. There we go. And what we want is this time down here, which is the start time of that particular onset. And that's where the tune actually starts. So that's where we want to start playing our sample. So let's put that in as 0.2943. And we can simply change that up here to say start 0.2943. It's not actually a time, it's the fraction of the way through the sample that we want to start playing. And so we'll now get rid of these two and go back to playing our sample, but when I press run, it'll start playing it straight away at the beginning of the tune.
Frere Jaques,
There we are.
Frere Jaques.
So let's move on to the next buffer, where we've got a program which is going to play our entire round for us. And this time we've got the loop being played here, and we're going to change the start time to correspond to the one we've just recorded, which is still highlighted on the screen up here, 0.2943. So let's change that to 2943. We've got the same tempo, which means that the delay we put between playing the loop the first time round and the next time round is equivalent to 8 crotchets. And if we just flick back to the first buffer briefly, you can see that those 8 crotchets correspond to the first 4 notes. They're played twice. Da 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 da. 8 of them, and the corresponding duration. These ones here. 1, 2, 3, 4. Da 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 da. And the corresponding notes are those 8 here. 1, 2, 3, 4, 5, 6, 7, 8. So we do that, and the other alteration is that we've added a pan command to the play, and initially the position of the pan is set to minus 0.9, right over on the left hand side of the audio spectrum, near the left hand speaker side, and each time we go round we're going to change that by plus 0.6. So the second time round it's going to be minus 0.3, the third time round plus 0.3, and the fourth time round plus 0.9. So let's listen to the final performance, which I've also amplified a little bit because the level is not that great, but it will make it sound a bit better. So here we have a performance of a 4-part round sung by one person using Sonic Pi.
Frere Jaques, 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 Sonny Libertina, Sonny Libertina, Sonny Libertina, Sonny Libertina, din dan dong, din dan dong.
And then finally we have another version where I've just played around a bit with each of the samples by putting some FX round them there and here, and I'm using the case statement from Ruby. This is basically a switch. It says case I, and I is going to go up from 0 to 3 the 4 times I go around the loop. When I is 0, and in fact when it's 2, it's simply going to play the sample straight. When I is 1, it's going to play it with an FX pitch shift of 12, up an octave, a bit sort of Mickey Mouse sounding, as you'll hear. And the last time round, when it's 3, it's going to play it with some G-verb on. It's going to give a sort of echoey effect. And the one thing we have to remember to do is to change our start time so that it fits, and that, remember, is 0.2943 from down here. So let's just change this up here, 0.2943. We've got the same BPM, so that means that the delay, sleep 8 crotchets, is going to work for each one. Here's the final listening.
Frere Jaques, Frere Jaques, do me vu, Sonny Libertina, Sonny Libertina, do me Jaques, din dan Jaques, Sonny Libertina, Sonny Libertina, Sonny Libertina, din dan dong.
So there we have it. I hope you've enjoyed the video, and why not have a go yourself?